Hello student, today we are going to start the Lagranges method of multipliers. Okay, in previous lecture we have discussed how to find an extreme value of the given function. Okay, in that lecture we have applied the second derivative test. What is the first step? Find the critical point, and then by using second derivative test decide whether given critical point is local maximum, local minimum or saddle point. Today suppose f of xyz and g of xyz be two differentiable function, Suppose we want to determine extreme values of f of xyz subject to the constraint g of xyz equal to 0, then solve the following equation. F is equal to f minus lambda g. This is also called an auxiliary equation. Form auxiliary equation f minus lambda g, where lambda is Lagrange's multipliers. Okay. Now, in many books, this equation written as f plus lambda g or del f is equal to lambda del g. Okay. Now, to solve this equation, you have to solve this whole equation. F of x minus lambda g of x is equal to 0. F of y minus lambda g of y equal to 0. F of z minus lambda g of z equal to 0, and g is equal to 0. So solve this equation number 1, 2, 3, 4. Solve equation number 1, 2, 3, 4 for lambda, and by using the value of lambda you can find the critical point of xyz where your function f may be a local maximum or local minimum. Okay, so this is the method of Lagrange's multipliers. By using this we can find an extreme value of the given function f of xyz subject to the condition g of xyz equal to 0. For example, consider find points on the ellipse. Find points on the ellipse x square plus 2y square equal to 1, where f of xy equal to x1 has its extreme value. Okay, so here we want to determine an extreme value of f of xy, but our xy should also satisfy this equation, x square plus 2y square equal to 1. Okay, so that is, there is some restriction on this function f of xy. In the previous lecture we directly find the extreme values of the given function because there is no constraint on f of xy. But if you observe, we want to determine an extreme value of the given function f of xy, but our xy must satisfy this condition, that is our xy must on the ellipse, okay, boundary of the ellipse. So here, what is f of xy? Since we want to determine extreme values of here, so f is equal to xy, and what is the condition? G is equal to x square plus 2y square minus 1. So form an equation, capital F is equal to f minus lambda g. So capital F is equal to xy minus lambda times x square plus 2y square minus 1. Now to solve, to find a critical point, we have to consider f of x minus lambda g of x is equal to 0. So this implies y, that is partial derivative with respect to x, and when we take a partial derivative with respect to x means what, your y is constant. So what is the derivative of this term with respect to x? It is y minus lambda times twice x is equal to 0. Okay, similarly, what is called this equation number 1. Then what is equation number 2? F of y minus lambda g of y equal to 0. So a partial derivative with respect to y. So when you take a derivative with respect to y means your x is constant. So it is equal to x minus lambda times 4y equal to 0. So this is equation number 2. What is equation number 3? G is equal to 0. Now G is equal to 0 implies x square plus 2y square equal to x square plus 2y square equal to 1. So by using equation number 1, 2 and 3 we want to determine value of lambda and then value of x and y. Okay, so if you observe on the first equation you can write y is equal to 2 lambda x, and from the second equation you can write x is equal to 4 lambda y. X is equal to 4 lambda y. From the second equation, if you take this term on the right hand side, you will get x is equal to 4 lambda y and y is equal to 2 lambda x. If you put this y equal to 2 lambda x in this equation, you will get x is equal to 4 lambda into 2 lambda x. So if you simplify this, you will get x is equal to 8 lambda x. Okay, so if you take this right hand side term on the LHS, will get, if we take this term on this side, we will get x minus 8 lambda x is equal to 0. Okay, from the left hand side you can take x outside, so 1 minus 8 lambda is equal to 0. But this implies case number 1, if x is equal to 0. Now what this implies? This implies either x is equal to 0 or this term will be 0. But if x is equal to 0, what happens? If x is equal to 0, our y is also 0. This implies y is also 0. But x is equal to 0 and y equal to 0 is not satisfied this equation, x square plus 2y square equal to 1. We want our xy must satisfy the equation of ellipse, or they must lie on the surface on that curve. Okay, so 0 0 is not lie on ellipse, or it is the center of the ellipse, and therefore x is not equal to 0. Okay, we want to determine x and y such that they also satisfy equation of ellipse. Okay, so here 0 0 does not satisfy an equation of ellipse, so x is not equal to 0. But x is not equal to 0 implies, if x is not equal to 0 implies 1 minus 8 lambda is equal to 0. There is one mistake. This lambda and lambda it will become lambda square. Okay, so here 8 lambda square, 1 minus 8 lambda square is equal to 0. So this implies 1 minus 8 lambda square equal to 0 implies 8 lambda square is equal to 1, and this implies lambda square is equal to 1 by 8, and and this implies lambda is equal to plus or minus 1 divided by under root of 8. Under root of 8 is what? 2 root 2. So this is the value of lambda. Lambda is equal to what? Plus or minus 2 root 2. Now next. Now, what is y is equal to 2 lambda x? So in this equation, if you put the value of lambda, okay, since y is equal to plus or minus 1 upon lambda is equal to plus or minus 1 upon 2 root 2, put in equation y is equal to 2 lambda x, we will get y is equal to 2 into plus or minus 1 upon 2 root 2 x. If you simplify this 2 will get cancelled here, and it is equal to, or x is equal to, if you take this root 2 on this side, you will get x is equal to plus or minus under root 2 y. Okay, so you will get some relation between x and y. Up to this point we have used only इक्वेशन नंबर 1 and 2. अजून आपण इक्वेशन नंबर 3 चा यूज केलेला नाही बघा. पण आता जर आपल्याला x आणि y ची व्हॅल्यू फाइंड करायची असेल तर we must apply equation number 3 also, because we obtain some relation between x and y. So what is the equation number 3? That is equation number 3, it is an equation of ellipse. X square plus 2y square equal to 1. So this implies root 2y plus or minus bracket square plus 2y square is equal to 1. If you put what is the x relation, we obtain the relation between x and y. What is x? Plus or minus root 2y. So if you put here, we will get 2y square plus 2y square is equal to 1. So what this implies? 4y square is equal to 1. So 4y square equal to 1. 4y square equal to 1 implies y square is equal to 1 by 4, and this implies y is equal to plus or minus 1 by 2. So if we obtain the value of y is equal to plus or minus 1 by 2. So x is equal to plus or minus 1 by 2, y is equal to plus or minus 1 by 2 implies what is x? X is equal to, if y is equal to, what is x? X is under root 2y and x is minus under root of 2y. So x must be 1 plus or minus, x is equal to, okay. So if y is equal to 1 by 2, then x is equal to plus or minus 1 upon root 2 y. Sorry, x is equal to, y is equal to 1 by 2. Then what happens here? X is equal to plus or minus root 2 into 1 by 2. So this implies x is equal to plus or minus 1 by root 2. 1 by root 2. Okay, so what are the critical points here? Critical points are 1 upon root 2, then 1 by 2, 1 upon root 2, minus 1 by 2, then minus 1 upon root 2, 1 by 2, and finally minus 1 by root 2 and minus 1 by 2. So these are the critical points. If you put here, x is what? Y is also plus or minus 1 by 2, x is also plus or minus 1 by 2. So if you put this value here, you will get, now these are the critical points. What is our f of xy? F of xy is equal to x into y. So f of plus or minus plus 1 by root 2 and 1 by 2 is equal to, it is equal to 1 upon 2 root 2, 1 upon 2 root 2, and if it is equal to 1 plus minus 1 by root 2 and 1 by 2, at this point is minus 1 upon 2 root 2. So if you take again, this is same as f of minus 1 by root 2 and minus 1 upon 2, and which is same as f of 1 by root 2 and minus 1 by 2. So if you observe, the what is the maximum value? Maximum value is 1 upon 2 root 2 at point 1 by root 2 and 1 by 2, or minus 1 by root 2 and minus 1 by 2, and what is the minimum value? Minus 1 upon root 2, that is minus 1 upon 2 root 2 at point minus 1 upon root 2 and 1 by 2, or 1 by root 2 and minus 1 by 2. So hope you understand this. Consider second example. Divide